So we're starting 1.2.3 day one lesson, but this entire first slide should be review. So what I'd like you to do is I want you to take the opportunity to see if you can get all of the questions answered on this page. And yes, some of the Y values are going to be approximations. So take a few minutes and see if you can figure this out. And then we'll come back together and we'll work on this and see how you did. All right, so taking a look at these problems, we have the graph that's been given to us. Notice the graph has not been called f of x or g of x. It's just been called y. And I think it's because one of the questions is it a function? So we have to be able to determine that. So if we take a look at this, we know that we are given the x value. So we have the x of -4, and our job is to find the y. So I'm going to go on the x-axis, so start at the origin. And I am going to go -4 in the x direction. So starting at the origin, I'm going to go -4 in the x direction. And then my job now is to try to figure out what the y value is or what the y values are. There might be multiple, that can happen. So I would go through and I would think of going up or down on the graph. So I'm going up or down to figure out where I'm going to hit it. And you'll see that I only have that one location that's down there. So if I count those boxes, it looks like it's 1, 2, 3, and I don't know, maybe a half. So -3.5. So over my answer, I would say y is approximately -3.5. And that is my estimate. Now I'm going to go back to my graph. And I'm going to erase what I put there so it's not too distracting for the next one. So if I take a look at the next one, x is 4, and I'm trying to, x is 1, and I'm trying to find the y. All right, let's get rid of those marks. And we want to go 1 in the x direction. So start here at the origin, go 1 in the x direction. And then from there, I need to figure out, I'm going to draw that line and try to figure out how many times I hit the graph. And I need those values. So, line's off a little bit. Okay, so there's our line. And it looks like it's hitting a couple of times. Okay, so I see right there, it looks like that's 2 boxes up. So I think I have a couple of answers. So y is 2. I don't know that it's approximate. Let's put an equal sign there. Y is 2. But then it also looks like it's hitting down as well. So 1, 2, 3. Okay. So it looks like y equals 3. And, because they're both answers, y equals 3. Okay. All right. So now I'm getting some information about whether or not I think it's a function just with question 2. So let's move on to question 3. So in question 3, I know what the x value is. It's 4. I'm trying to find the y. All right, so let's get rid of the marks on my picture just so I'm not distracted by it. Okay, I'm going to go out to x equals 4. So from the origin, I'll go 1, 2, 3, 4. I'm going to draw my line there to figure out where I'm hitting on the graph. And it actually looks like 3 spots this time. So I'm going to go ahead and highlight my 3 spots. So, well, one of them is right at 0. So it looks like y equals 0. And, okay, looks like I'm going up 1, 2, 3 and a tiny bit, so maybe like 3.2, 3.3. But I think there's another one as well. So it looks like it's down 1, 2, and a little bit. So maybe -2.3 or -2.2. So it looks like I have a couple of answers there on that one. And then based off of this, I should be able to look and see if I can determine number 4 and see if this is actually a function. And I don't think that it is because of my answer from 2 and my answer from 3. So at this point, I would say this is not a function. This is no. And you can use your answer from 2 or your answer from 3 to say why. So I would say since x equals 4 has 3 different outputs. Now, I did hint at last class that there was like a name for this if you're taking a look at the graph, which it is. Oh, and I see. So 1, thank you very much. There was a correction on this. So if we go back to question number 2, if x is equal to 1, I think that y is a -3. So let's fix that. And thank you for the correction. Okay, I think we're good now, hopefully. So I did say that there was an issue or there was a name for this, and it really is the idea of once you go out to an x value, if you draw a vertical line there and you're trying to determine if you're hitting the graph more than once, that is called the vertical line test. So I'm going to turn it purple just so it doesn't mess with my green and my orange here. If you draw a vertical line anywhere on this graph, you want to determine if this graph or that line hits the graph in multiple places. So kind of referring back to what we did last class. Another way to say, no, it's not a function, we would say that's because the graph fails the vertical line test. So that's another thing that we could say. Okay. Now this should look familiar for sure, just like the first one did. So if we take a look at this, we have our function machine. I also put this image on that images sheet for you guys, okay? I want you to go ahead and see if you can calculate and do 5 and 6. So I want you to attempt questions 5 and 6. Let's just review. I am going to give you about 5 minutes on 5 and 6 just because of the fraction part of it too. Okay, so on question number 5, you're being asked to do kind of what we've been doing since the beginning when we first started functions. We have this function machine. We know that we're dropping an x value into the machine. The machine's doing some work. And then we have a function value, so like a y, that pops out at the bottom. So if we go through and we take a look at these, if we have f of -3, that means this is an x value. So wherever we see an x inside the function, we're going to plop that -3 inside. So this is going to give me 6 over, all right, there was an x, so I'm going to take it out and replace it with parentheses, and then -3. So that's the f of x function. Now I'm just going to drop in the number that I was given, so -3. So kind of keeping up with my color coding here. Remember that the left-hand side is just notation, so leave it alone. Just bring it with you. So I'll get 6 over, okay, I don't like that subtraction sign there, so I think I'm going to turn it into a negative and then an addition problem. So in the bottom, I'm going to get a -3 plus a -3, which I know is a -6. And then I know that a positive divided by negative is going to be negative, and I know 6 divided by itself is just 1. So I'm going to drop my notation all the way down. So f of -3 is equal to -1. So that's my x value. There's my y value. And that is my answer for the first part. Okay, same process on the next two. So I'm going to do f of 0. So that's my x value that I'm plugging in. So I'll write my function. Wherever I see an x, I'm going to take it out and put parentheses in its place, and that's where my 0 is going to go in. I don't like the subtraction on this one either, so I'm going to go ahead and fix that and turn it into a negative with a plus sign. I'm going to do the math on the left-hand side. Okay, 0 plus -3 is -3, and then a positive divided by negative is going to be a negative, and 3 goes into 6 2 times. and then drop your notation down. So f of 0. So inside is x, outside is y. So my next answer is f of 0 is equal to -2. Okay, my last one, same process. So f of 2, all right, that's the x value that's being plugged in. I'm going to go ahead and start writing the function. Open a set of parentheses where the x is located so I can take it out and I can plug the 2 in inside. I don't like this subtraction either, so I'm going to turn it into a negative with a plus sign. So then that's going to give me 6 over, 2 plus -3 is going to be -1, and I can do that division, and I believe that that's -6. Bring down the f of 2 notation. There's my x, there's my y, and there's my answer. So I like this question because it gives you a little bit more practice with fractions. And then it is a function. We were told that it was a function because of the f of x notation. Remember, can't use f of x notation if it's not a function, which is why I didn't call the one on the first slide f of x, because I knew it wasn't a function. I just called it y. Okay, moving on to 6. All right, so same idea. The input here is my x value, which is 3. So I've got f of 3. That's my x. I'm going to set it equal to my function, take the x out, and then plug in the 3 where it belongs. I'm okay with that subtraction. It doesn't bother me. So I'm not going to turn it into add a negative. So I'm going to get 6 over 3 minus 3 is 0. I'm very concerned at this point because, and this was something you and I talked about a couple of weeks ago, we don't know how to divide by 0. Remember that division is just another version of multiplication. So what this really means is that 0 times something has to be 6. So 0 times, so the bottom times some number has to give you the numerator. However, you and I both know that 0 times anything is just 0. So we can't get 6. This can't happen. So I'm going to put a little slash through my equal sign. Whenever you get something that is simply cannot happen, or specifically if you're dividing by 0, we would say that this is undefined. So I would say f of 3 is undefined. What that means is that if I plug 3 into the function and I tried to graph this thing, I wouldn't get any y value out of it at all. There would be no graph there. So it would go 3, and then if you went straight up or straight down, you wouldn't hit the curve. There wouldn't be anything there. So that leads us into question number 7. Are there any x values that can't be plugged in? Well, I think it's because of the whole dividing by 0 part. So, yeah. So let's think about what we know. Since we can't divide by 0, which means the denominator cannot be 0, we can't plug in any x that makes the denominator 0. So in this case, the thing that if we plug it in makes the denominator 0 is 3. So just like what we did in number 6, x cannot, it's not allowed to be 3, because when it is, we get something that is undefined. We get something that's not even on the graph. So the reason that we were talking about the things that you can and can't plug in is we're trying to build up to something else about functions, and that's the idea of domain. Now, we have the official definition here, but I did rewrite it again for you just in case. The domain is the set of all inputs, so x's, for which there is an output, a y. Well, there's a couple of ways to do this. It's the X values that you're allowed to plug in. So if we want to think about the last example. But another way to look at it with the graph is like, where could you trap your graph between? So if you're trying to put it into like a little cage or like pin it in or box it in, we want to figure out how far to the left, because we always want to go small, start small. And since we read left to right, and that's the way that the number line works for us, small numbers on the left, bigger numbers on the right, we want to think of how far does our graph go to the left, and then how far to the right does it go? So like, where could I kind of block it in? So that's what we're going to do for this. And we're only looking at the X's. We're only talking about domain today. We'll talk about its counterpart next class. So here it's all about domain. So I'm going to use my orange pencil. And what I want to do is kind of want to step back and really take a look at the entirety of the graph. And I want to figure out, okay, as I'm looking at the circle, it's going to be my first one. As I'm looking at the circle, what is like the farthest edge to the left that the circle has? So I look at it and I'm like, okay, it looks like this point on the far, far, far left is the kind of the boundary to where the circle doesn't exist to the left of it, and then it starts existing on the right of it. So I'm going to go ahead and kind of block it in. So like pin it in, like I said. So I'm going to put a little kind of like a cage around it, I guess. So I would say the furthest this thing goes to the left is -2, since that's where it is on the x-axis. Now, the graph, all the graphs that you and I are looking at today are all connected. So it's not like random dots. We'll talk about that later. These are all connected. So if I started at -2, that'd be the furthest to the left. Now I want to go all the way to the right and figure out how far to the right my graph goes. So I'm going to do the same thing, kind of go to the edge of that circle. And it looks like it's going to be over there. So I'm going to go ahead and continue kind of like trapping this in. So this is going to be at 6. So I would say my domain here, so that's all I'm doing at this point, my domain, and we're just going to say it in words, is from -2 to 6. That's all. So that's my answer for the first circle, for the first question. It's kind of like, where could I like trap it in nice and tight on the X direction? So from left to right. All right, let's take a look at the second one. So I'm looking at the second one, and I want to try to like trap it inside, so kind of block it in. Okay, so as I go to the left, so I just keep thinking about to the left. All right, if that's my orange line, there's still more graph to the left, so that's not it. If that's my orange line, no, there's still more graph to the left, that's not it. If I do my orange line, there's technically more graph to the left because of the arrow. So not only is that arrow, if you look carefully, it's pointing up for sure, but it's also tilted a little bit to the left. Since it's tilted a little bit to the left, that means it's going to keep going out. Slowly, but it's still going to the left. So if there's an arrow, it's going to keep going in that direction forever. So it's going as far to the left as I can imagine. As far to the left as I can imagine is the smallest number I can think of, which is going to be negative, because it's the smallest number possible, and it's going to be infinity. So over here, I would say this is going to be -infinity. Okay, let's look at the right-hand side. Same idea, trying to trap it in. Okay. Nope, there's still more stuff to the right. That's not it. Still more stuff to the right. That's not it. Even there, there's still more stuff to the right because I still have that thing pointing to the right. Now, it's important to note, we're all, I think, probably pretty comfortable with infinity. But infinity, with no sign in front of it, is assumed to be positive. anything that is positive infinity is the biggest number you can imagine. So the sign difference in front is basically telling me the smallest number I can imagine versus the biggest number I can imagine. So since this one is pointing to the right, it's pointing to the biggest number I can think of. That's positive infinity. So put a little note over here for ourselves. So negative infinity tells us that this is the smallest number we can imagine. Whereas positive infinity, that is going to be the biggest number we can imagine. And it really is just the idea that there is a bigger number out there, because infinity isn't a number, it's just a concept. So in this case, I would say that my domain would be negative infinity to positive infinity. Now you guys know if something's positive, you don't have to put the positive sign on it. You can, but you don't have to. Now, as we know that we're building up to assessments, if this is in Schoology, which it's going to be, there's no infinity symbol, so you guys are going to have to write it out. So we would do negative infinity to infinity. And I hope that helps with the description between what a negative infinity concept is and what a positive infinity concept is. Let's move on to the next one. Same idea. So if we take a look at this, exact same idea. We want to go from left to right. Use the arrows to help yourself out. So if we take a look, furthest to the left, the furthest section to the left that I see is that arrow. Yes, it's pointing down. I understand that. But it's not pointing straight down. It's pointing down with a tilt, which means it's still technically going to the left. So I would say that this is going to be to negative infinity, the smallest one I can possibly imagine. I'm going to do the same thing on the right-hand side. So take a look at the right-hand side. So I'm stepping back and I'm looking at the whole graph. Right-hand side, well, the right-hand side has an arrow. Take a look at how the arrow is pointing. Yes, it's pointing up, but it's not straight up. It's pointing with a tilt. And because of that tilt, it's still going to be taking off to the right. And the right is the biggest number we can possibly imagine. So for my domain here, I would say small is negative infinity, or the left side, to the right side, which is positive infinity. And again, on Schoology, we would have to write out, and you don't have to write out the word negative because we do have a negative sign there, but we would have to write out infinity. So negative infinity to infinity. Okay, let's take a look at the next one. And then after this, we've got two more. Again, you guys can take a look at the images that I gave you. So take a look at this. Just kind of stand back, take a look at the whole thing. We want to look as far to the left as we possibly can. As far to the left as we possibly can, I see an arrow. Well, got to think about what that arrow is doing. All I care about is left-right movement at this point. Yes, it's pointing down, but it's not straight down. It still has a little tilt to it. If it has a little tilt to it, it's still technically going left. It's slowly going left, but it's still going left. So that is going to be the smallest number I can possibly imagine, negative infinity. Take a look at the right-hand side. Furthest to the right, I see another arrow. Yes, it's pointing up, but it's not pointing straight up. It's got a tilt to it, which means it's still technically going to the right. It's slow, but it is going to the right. So I have that my domain on this one, interestingly enough, is the same as the domain on the previous question on this slide. But look at how different the graphs are. So you can have the same domain, but that doesn't mean the graphs have to be the same. again, get into the habit of making sure that you write it out, only because we're using Schoology. If we were in person, we could just go ahead and write down that negative infinity symbol. Okay, our last two ones. So again, on your images page, we take a look at this one, or these two. I want you to see if you can do them. And then we'll check and see how you did. Okay, so these questions should be pretty quick as we're looking left to right. On this graph on the top, there's clearly like this little bump on the side where my graph starts coming back. So I think we do have a furthest to the left location. So it looks like it's going to be at -3. So if I look at the x-axis there. But if I take a look at the right-hand side, those arrows are clearly pointing to the right. They're even pointing up and down slowly, but they're definitely pointing to the right. Both of them are. And so we know that would be positive infinity. So my domain here would be -3 to infinity. If you wrote it out in words, we'll just make sure that we write out infinity for the next one. Okay, and then the last one here. This one, I like this one because it is clearly a flat line, clearly. So as it's moving to the left, it is strictly going straight to the left. Like the arrow should be very obvious here. Since it's going to the smallest possible number we can imagine, that would be negative infinity. And then our biggest positive number, biggest number we can imagine on the right-hand side. So our domain here was negative infinity to infinity. And then if you wrote this out, okay, that finishes our notes for today.